Over here, and this is the 2020 AMC 12B problem 21. Here's a view of this problem. How many positive integers n satisfy n plus 1000 over 70 is equal to the floor of the square root of n? And then recall that the floor of n is just the greatest integer not exceeding x. Or in other words, we just round down. Okay, so how can we even comprehend this? Well, the right hand side is saying the floor, and we know that the floor will always be an integer. Therefore, for this equation to be true, the LHS must be an integer. So we have that n plus 1, upon first observations, we have n plus 1000 over 70 must be an integer. Okay. Okay, and then now the question is what n works. Well, first, we should notice that, well, what happens when n is a perfect square? When n is a perfect square, we take the square root, we're just going to get that perfect, that value of n, and then taking the floor, we're going to get that value of n. So therefore, let's consider the case when n is a perfect square. So let n equal k squared. If n is equal to k squared, we have k squared plus 1000 over 70 is equal to taking the square root and flooring that will just give us the integer k. I should add that k is some integer. Okay, and then now multiplying both sides by 70 and bringing the 70k over gives us k squared minus 70k plus 1000 is equal to 0. This can factor as k minus 50 times k minus 20 is equal to 0. Okay, so k equals 50 or 20. So k being in the set 20, 50 means that our respective values of n are gonna be 20 squared, which is 400, and then 50 squared, which is 2500. And as a quick check, we can plug this in. This gives us 20 square root. Both of these work. Alright, so now we may be hasty enough to circle 2, and our answer would be wrong. The reason being that we can have this being an integer. And when we floor this decimal expansion, we get an integer as well, which is equal. So let's consider when n is equal to 400. N is equal to 400. Well, what happens if we just discussed that this must be an integer, right? So meaning that we must add or subtract multiples of 70. So what happens when n is equal to 470? And I might just, for convenience, just let t equal n plus 1000 over 70. When n is equal to 470, what's happening is we are taking the 20 and we're just adding 1. So t is equal to 21. So we get 21 on the LHS. What's happening in the RHS? Well, we know that 21 squared is 441 and 22 squared is 484. Therefore, when flooring the square root of 470, we're going to get 21. So this matches, we found another value of n. Let's perhaps move up one. N is equal to 540. We just discussed we're going to be adding 2, so t is equal to 22. 22, so this is 540. When taking the floor of the square root of 540, we know that 23 squared is 529, and then 24 squared is 576. Therefore, we're going to floor this, but we're going to get 23. So therefore, this doesn't work. And if you're not convinced, you can try a couple more values, and we see in general, none of these are going to satisfy until we reach another perfect square satisfaction, which is 50 and 2500 precisely. So let's move on to n is equal to 2500, where we know we'll find the other solutions, if any, that is. N is equal to 500. Well, when n is equal to 500, we just discussed that t is equal to 50. That's obviously a solution. Let's move up one, 2570. When n is equal to 2570, we're going to get 51 over here. 51 squared is 2601. So therefore, when taking the square root of this is actually going to floor down to 50. And we want this to be 51. Therefore, this is not going to work. And using the same argument, none of the other values are going to work because this graph is going to be above this graph now. Alright. So now that this is done, we still have to move backwards, right? What happens when n is equal to 2430? When n is equal to 2430, what's happening? T is equal to 49. That means that 49 squared is 2401. This is gonna floor down to 2401. So this is good. N is equal to, let's go down to 2360. And then T is equal to 48. 48 squared is what? 2304. And 49 squared is 2401. So this is gonna floor down. This is good. And then N is equal to 2290. Let's just try this. T becomes 47. And we're just going to test all the values because we know they're not going to be too many. 2290, what happens is 47 squared. I actually don't know the value of 47 squared. Let's see. 47 squared, 94, 28, 32, 0, 8, 2, 18, 9021, 2209. So 2209 versus 2304, this is still going to floor down. But now we actually see that there's not too much of a gap, meaning that we're closing down on our solution. So on our so 70, 22, 20 is our next one. This happens when t is equal to 46. But when upon taking the wait, hold on. What's 46 squared? 36, 3, 24, 27, 0, 4, 2, 18, 1, 6, 1, 1, 27, 16. Okay. So upon taking the square root of 2220, we see that we're actually going to be flowing down to 47. So this doesn't work, and so on, meaning that we only have this as a solution, 1, 2, this as a solution, 3. We also have, we can't forget this, 4, and then we have 470, and then we also have 500, or 400, for a total of 1, 2, 3, 4, 5, 6, C, and we are done.